So good afternoon. We're going to continue working with a system of equations. We're going to try a different strategy called the elimination method. So, one of the things we learned so far is when I have a system of equations, I can graph to find the solution to the system. I can use what we call the substitution method to find the solution. And then, of course, we're going to look at this third method. What I want to do is look at solving this system by graphing again. Now, since these are already in standard form, I think it's probably easier to just go ahead and just find the x and y intercepts. So let's start with this first line. So if I want to find the x-intercept, I set y equals 0, so I get 4x equals 20. And divide by 4, we get x equals 5. That's going to be our x-intercept. To find our y-intercept, we set x equals 0. We get negative y equals 20. So we'd have y equals a negative 20. What I'm picking up on is on my graph, I actually can't graph the y-intercept of negative 20 here. My graph doesn't go that far. It looks like it only goes to about 18 there. So it looks like that method is going to be off the book. I'm going to go ahead and just find the slope and the y-intercept then. So we have 4x minus y is equal to 20. I'm going to kind of isolate the y, so I get this subtract 4x on both sides. Let's see where this takes me. So I get negative y equals negative 4x plus 20. Take the opposite of each side, I get y equals 4x minus 20. So if I change the signs. Again, I'll say that even in slope intercept form, my y-intercept is going to be a negative 20, so I'm not really going to be able to use that. So I'm going to have to probably make a t-chart. So let's just pick a value like, say, maybe x to be maybe 2. If x is 2, this is going to give me 8 minus 20. That's going to give me, is that a negative 12? That looks like I can fit that on the graph. And let's pick, my x-intercept was 5, so I also have 5, 0. So if x is 5, then I'm going to get 0 for y. So let's use those ordered pairs. So I get 2, negative 12. So you can kind of see some of the downsides of graphing. And then I have a 5, 0. So those are going to be my points that I can now use to graph the line. Okay. So I'm going to go ahead and get rid of this math. Don't have enough room for all this. See if I can get that off there. Let's look at the second equation. Looks like here the y-intercepts aren't going to be so bad. So the x-intercept for the second one, I'm going to set y equals 0. I'm going to get negative 2x equals 10. So x should equal a negative 5. The y-intercept, we're setting x equals 0 and solving for y. We get negative 2y equals 10. And we get y is equal to negative 5. So it looks like we get a negative 5 and a negative 5 for the y-intercept as well. So I can now graph the line. kind of picking up on this point of intersection. So that's going to be my solution. So it looks like I'm going over 3 and down 8. So 3, negative 8 would be my solution. Okay, so that would be graphing it. And I ended up having to go to a T-chart to find some ordered pairs. So I actually had to go back to our very first strategy when we were graphing ordered pairs. So let's see how the elimination method plays out in this problem. If you were noting that we've already did this problem by the substitution method as well, so you can kind of compare which was easier. So the first thing it says, put the equations in standard form. Again, standard form, we have this ax plus by is equal to c. And preferably a, b, and c are what we call positive or negative integers. We don't want any fractions or decimals if we can avoid them. So we're in standard form already, so step 1 is done for us. What I want to do is make a coefficient the same number but opposite in sign. So looking at the coefficients of x, notice that they're not the same number, but they are opposite sign. If you look at the coefficients of y, they're not the same number and they're also the same sign. What I want to do is I want to make either the coefficients of the x's or the coefficients of the y the same number but opposite in sign. So essentially what I'm looking for is a common multiple. I'm going to look at the 4 and the 2. So the 4 and the 2, I can pick up that a common multiple would actually be 4. So I can make them both a 4, and since they're already opposite sign, I don't need to worry about that. So to make this 2 change into a 4, I needed 2 2's to make a 4. So what we're going to do is, to make the coefficient the same number, is we're going to multiply this whole equation by the same value. So my next move is then, I'm going to rewrite 4x minus y is equal to 20. And I'm going to multiply the second equation by a 2. So I have a 2 times a negative 2x minus 2y. And remember, whatever you do one side, you got to do it to the other side to keep it balanced. So I'm going to have a 2 times 10 over here on this side. Okay, I'm going to slide over here and rewrite this one this way. So I have 4x minus y is equal to 20. And I'm going to multiply the 2 through the parentheses there. So I got a negative 4x minus 4y is equal to, actually that's going to be 2 times 10, which is 20. So notice that to create this coefficient, you had to multiply both sides by that same value to keep that equation balanced. So remember, with the equation thinking, whatever you do one side, you can do the other. And by multiplying by 2, I'm able to make the second equation have the same coefficient as the first equation, and it is opposite in sign. And that's what we're trying to do here. Make a coefficient the same number but opposite in sign, and we've achieved that now. So now we're ready to do our next step. Add the equations together to eliminate a variable. So we're going to add these two equations together, and we're going to see that this 4x and this negative 4x are going to zero out. So what we have then is a negative 5y is equal to a 40. So negative y and negative 4y will give me a negative 5y, and 20 and 20 will give me 40. And then I can get y by itself by dividing each side by a negative 5. And so y will equal a negative 8. I'm feeling pretty good about that because that was what my y value was over here. So I added the equations together to eliminate a variable, and we went on and solved that variable for, that. So our next move then is to substitute this value into an equation to find the value of the other variable. So notice I have y equals negative 8. I got a slew of equations. I'm just going to go back to the original equations, and I want to substitute into one of these original equations. And notice I'm going to substitute negative 8 in for y. So I really don't see much difference between these two equations. So I'm just going to go ahead and substitute into the second equation, the top equation here. So I'm going to use this 4x minus y is equal to 20. But notice how y is equal to negative 8, I'm going to replace this y with the negative 8. So what I have then is 4x minus, and I'm going to change that y to negative 8. And then you have equal to 20. So what we have then is, I'm going to now see that I can solve for x, so it's going to be 4x plus 8 is equal to 20. I can then use a zero pair to knock this 8 out. And I have then 4x equals 12. And we should see x equals 3. So when I substitute in, I'm just going to substitute back into one of the original equations. I did so, and I was able to solve for the other variable. So now we have the value for x, and we have the value for y, and we've got our solution. We can kind of pick up on that. 3, negative 8 would be my solution. Remember that the x value has to go first, the y value has got to go second in an ordered pair. And that does confirm what we had over here. But we did it a totally different way. We used what we call, some people call it the addition method, some textbooks call it the elimination method. And I kind of like the elimination method because that's kind of what we're doing is we're eliminating a variable out of the problem to make a single variable equation. Okay? So we'll try a few more of those. Stay tuned.